We present Hybrid Tours, a clip-based system for authoring long-take touring shots. In cinematography, long-take touring shots are characterized by smooth camera motion over a long distance that seamlessly connects different views of a scene. This type of shot is often used to establish new settings in film or to showcase large spaces for applications in real estate or tourism. There are two general strategies for creating these shots. The traditional approach is to plan the shot ahead of time, then capture the entire video in one uninterrupted take. We'll call this the all-real approach. This approach is the golden standard for quality when executed well, but it can be extremely difficult to pull off. So it's typically limited to professionals using specialized equipment like a Steadicam or drone. More recently, people have started to explore what we'll call the all-virtual approach, where the user starts by capturing an abundance of images from a wide range of angles. Then they register these photos using structure from motion and use the registered images to train an image-based rendering algorithm like NeRF or Gaussian splatting. This process can be quite expensive, and the visual quality doesn't quite match real results, but the advantage is that it lets users plan and execute camera trajectories using virtual tools like NeRF Studio. And since the input images don't have to come from a smooth video, this approach can work with regular hand-captured photos and video as input. Our work observes that these two different approaches to making long-take shots are really extreme ends on a spectrum of approaches that balance the difficulty of capturing long takes against the cost of reconstructing large scenes. Based on this observation, we designed a new workflow and system called Hybrid Tours that addresses challenges from both ends of this spectrum by using short clips of video as a basis for capturing, reconstructing, editing, and rendering long-take shots. This has several advantages. When filming, short clips are much easier to capture than long uninterrupted shots, and our system makes this even easier by connecting and filtering hand-captured videos so they don't need to be perfectly stable when captured. And as we detail in the paper, our workflow makes it easy to produce higher quality visual results at just a fraction of the time and compute costs used by existing all-virtual workflows. And as we'll demonstrate in a moment, our interactive editor represents long-take shots as filtered sequences of these shorter clips, which makes it much easier to incorporate framing and composition choices made during capture into the design of virtual camera trajectories. We'll leave the details of these first 2 points to the paper and supplemental, and focus the rest of this video on demonstrating our novel interface for pre-visualizing and editing virtual camera paths and some of the results that it can be used to create. The user starts by capturing a set of short clips that approximate potential segments for a long-take shot. These clips don't have to be smooth, as we will use our reconstruction to filter their trajectories later. But we will use the framing and composition choices made in these shots to design our virtual camera path. More specifically, these candidate clips act as a basis that spans different long trajectories we can create with our tool. After capturing the data, we perform a fast reconstruction on a small subset of the video frames to enable fast pre-visualization and path planning. We now demonstrate how to edit these clips into a long-take shot using our interactive tool.
In the editing interface, all candidate clips are listed on top. The user can start by dragging and dropping candidate clips into the selected clip slot. The system also automatically suggests good choices of subsequent candidate clips. Besides incrementally selecting candidate clips, the user can just specify which candidate clips the final camera trajectory should go through and let the system to fill in the remaining ones to create a smooth camera trajectory. Then, the user can click on the Candidate Clips button to actually create the final long-take camera trajectory. Then, the final camera trajectory is pre-visualized on the two canvases in the middle, from both a third-person perspective and a first-person perspective. The user can toggle this switch to stabilize the camera trajectory and unlock all the editing widgets. The user can change the stabilization strength, trim the final video, and retime it either locally or globally. To apply the edits, the user can click on the Update Video button. The user can also use the velocity smoothing slider to make the translational velocity of the camera constant throughout the whole video. If the user is satisfied with the final result, the user can click on the Render Video button and type in the video's name to render it.
And here's the rendered result of that session.
The candidate clip suggestion feature is extremely useful for managing a lot of candidate clips. In the garage scene, we can specify a starting candidate clip and a car that the concatenated camera trajectory should end at, and let the system figure out which candidate clip should be used. Besides this black car, we can let the system figure out another path to this blue car. Based on the garage dataset, we create 5 videos that start outside of the garage roughly at the same place and end at 5 different cars inside the garage at different floors. Please refer to our supplemental material for the individual video file.
By letting users break long, complicated shots into smaller pieces that are easier to capture, it also makes it possible for users to capture shots that would be normally impossible given other physical constraints. We can also use hybrid tours to create videos that smoothly blend between rendered footage and real footage. In this example, found in our supplemental, we use that ability to create a shot that starts in the daytime, goes on a 2-minute tour, and then comes back to find that it's nighttime. As we analyze in our paper, hybrid tours also produces higher quality visuals with just a fraction of the time and resources used by standard all-virtual workflows. Our work provides an exciting way for users to create long-take shots with comparatively little resources, and opens a rich space of opportunities to explore in the spectrum of real and virtual workflows. For more details, please see our paper and supplemental material. Thank you.